Hey everyone, and welcome to a video titled Power Rule for Exponents. So Algebra 1 students, you know we've been working with different rules for exponents. Yesterday we learned the product rule. Today we're learning what's called the power rule. So just like I did yesterday, I'm going to start by giving you the rule. It won't make much sense at first, but by the end of this lesson, it will make sense. So here's the rule, plain and simple. If you're taking a quantity, a x raised to the b power, and then all of that is raised to yet another power, which I'm calling m here, then the answer to this problem is a raised to the mth power, x raised to the b times n power. So it's like this guy right here, the coefficient of the x gets raised to the mth power. So you see that right here. But then with the x to the b, x gets raised to the product of b times m. So what the heck is going on there? We have no idea. But I'm going to go through some examples here, and hopefully we'll come full circle and you'll understand why this rule is what it is. So let's go down here. We have 4 examples today. Let's start here. It says simplify, and let's start with number 1. Okay, so we're taking, in this first example, we're taking x squared and we're raising it to the 5th power. Now, let's talk about what this actually means. So I want you to focus your attention on the exponent that is outside the quantity, which is the 5th. So you're taking an x squared and raising it to the 5th power. Well, let's backtrack like we did on the last video. Let's say I wanted you to take 2, just the number 2, something very simple, and raise it to the 5th power. Well, you learned long ago that taking 2 to the 5th power means you're going to take 2 times 2 times 2 times 2 times 2. You're going to take 2 times itself 5 times over. And if you do that multiplication, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 2 gives you a final answer of 32. So that's kind of old hat. Now let's apply this to our new problem here. Well, the only difference is instead of having 2 to the 5th power, we've got x squared to the 5th power. So all I'm going to do is write x squared times itself 5 times. So 1, 2, 3, 4, and 5. Okay, now you know from yesterday's product rule we can break each of these x squareds down further. So let's do that. So this x squared right here means x times x. Then I have this times sign, and this guy right here means x times x, and a times sign, x times x, x times x, and finally, x times x. So remember my philosophy, break it down to build it back up. Let's count now our final number of x's. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My final answer to this problem is x raised to the 10th power. Okay, so here's the shortcut. What's 2 times 5? Well, 2 times 5 is, bingo, 10. And when you're doing that shortcut, what you're kind of thinking is, I've got 2 x's 5 times over. So if you've got 2 x's 5 times over, that makes a total of 10. But that's a shortcut. That really is showing this part right here of the rule. So forget the a for right now. We didn't have the a. Just focus on this part right here. We just had an x squared, and we raised it to the 5th. So that kind of takes care of why this part becomes x raised to the b times m, or in this case it was 2 times 5. In the next example, we'll get a coefficient and kind of explain how that works. So let's move down to example 2. We're taking 2p to the 6th, all raised to the 3rd power. So again, let's focus on the exponent outside the parentheses. I want to take 2p to the 6th, that's what's inside the parentheses, and I want to express it multiplied by itself 3 times over. So that's going to look like this. 2p to the 6th times 2p to the 6th times 2p to the 6th. Simple. 3 times. But we know these can break down further. So let's break these down. This one is going to be a 2 with 6 different p's attached. So I'm going to write them out. 1, 2, 3, 4, 5, 6. That's 2p to the 6th times, now I'm going to do it again, 2 and then 1, 2, 3, 4, 5, 6 times, and here comes the third one, 2 and 1, 2, 3, 4, 5, 6. So we broke it as far down as we could, and now we're going to build it back up to get our final answer. Okay, so let's do the math. We've got a 2 times a 2 times a 2. 2 times 2 is 4. 4 times 2 is 8. So I'm going to start out front with an 8. And now I'm going to count my p's. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So p raised to the 18th power. That's going to be my final answer. Now let's backtrack for a second. If you think about yesterday's lesson, we learned the product rule for exponents. So when you're multiplying something like this, we learned yesterday that the shortcut is to add these guys. Because if you have 6 and 6 more and 6 more, then you've got 6 plus 6 plus 6, and 6 plus 6 plus 6 is also 18. So if you didn't want to write out all of these p's down here, you could think of it as 6 plus 6 plus 6. Now, let's back it all the way up to the original problem. If you want to avoid all of this and go straight from the original problem to the answer, here's how you do it. But this involves some memorization. First off, let's just look at this part. Just the p raised to the 6 with this 3 outside. Just like in the prior example, 6 times 3 is 18. So that is this part again of the notes, or the rule up here. Those get multiplied. But now let's talk about what happened to the 2 in the front. So what happened with this 2 and this 3? Well, oftentimes people will do the wrong thing with the 2 and the 3. They'll multiply the 2 and the 3 because they figure, hey, I multiplied these to get 18, so why not multiply 2 times 3 to get 6? But you see here, that's wrong because the coefficient's supposed to be an 8. So what has to happen with a coefficient, not an exponent, a bigger guy in front, and the exponent outside, is that that coefficient must get raised to that power. 2 to the 3rd power is 2 times 2 times 2, which indeed is 8. Another way some students have thought about it, and this actually is pretty good too. Let me turn this to the back to show you. So let me rewrite the original problem. So it was 2p to the 6th, all raised to the 3rd. If you like this better, feel free. 2, the coefficient, really does have an exponent. It's 2 to the 1st. So if you want to keep consistent with the rule, what you could do is you already know you're taking p to the 6 times 3. You could do 2 to the 1 times 3. That way you're multiplying these and these. And that will also get you the correct answer, because 2 to the 3rd, p to the 18th is 8p to the 18th. So you could think of it like that as well, and then you keep consistent with that multiplication, inside, outside, inside, outside. That might be a little bit easier. Okay, 2 more to go and we're done. So let's take a look at number 3. Now, you could pause the video right now. You could pause me, and you could try to do this by the shortcuts. Like, you could try to do this by the rule or by what I showed you back here, and then see if you get it right. I'm going to do it the long way first, just like I've been doing everything, because when in doubt, I write it out. And I see no harm in going through this. I'm not afraid to write some things down. Here's what's interesting about this one. We have this 6 clear out in front of this parentheses. So this 6 is not being raised to the 5th power the way this monomial inside is. So I'm just going to bring 6 along for the ride, and maybe at the end of the problem I'll be able to do something with it. So I'm going to start with a 6, just write that down, times. And now I've got to write out this monomial, 3m squared p to the 4th. I've got to write that out 5 times over. So here I go. 3m squared p to the 4th times 3m squared p to the 4th. 3m squared p to the 4th. 2 more. 3m squared p to the 4th. And finally, 3m squared p to the 4th. So that's 1, 2, 3, 4, 5. But of course, each of these can go further. So again, let's bring that 6 down. And now I've got 3 times m times p, 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 p. And I'm going to go again. 3 times m, p, 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 p. And I keep going. 3 more times. 3 times m, and p, 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 p. 2 more. 3 times m, and p times p times p times p. That's 1, 2, 3, 4, and I've got 1 more to go. I have to come down here a line. 3m, 1, 2, 3, 4. My goodness, that's a lot of writing. Okay, so I broke it down. Now I'm going to build it back up. So I'm going to take 6 times 3 times 3 times 3 times 3 times 3. Whew! Okay, well, I'm going to grab my calculator for that, because I don't know if I know that off the top of my head, and I don't want to make a mistake here on the notes. So 1, 2, 3, 4. So 5 3s and a 6. So let's get this going here. So 6 times 1, 2, 3, 4, 5. Looks like 1,458. Okay, so that's going to be my coefficient in the very front. So 1,458. Now let's count the m's. Here we go. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, m to the 10th. And let's count the p's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So p to the 20th. Final answer. So if you paused me earlier, is this what you got? If not, that might tell you you're not a person for shortcuts. No offense, but if it's me and we know like the Keystone exams are coming up, I'm going to take the extra time and just write it out so that I'm sure, because these rules can get jumbled in our heads. You may be adding when you should be multiplying, and multiplying when you should be adding. If you just write it out and count, you cannot go wrong. So something to think about, but let me show you how to do it by the shortcut. So let me turn this over and recopy it. So it was 6 on the outside. On the inside, it was 3m squared p p to the 4th, and this was all raised to the 5th. All right, let's do this by the shortcut. I actually kind of like to work, no, actually I'm not going to do that. Forget that. Let me do this. Let me start by taking the coefficient in the front, the 3, and raising it to the first power, because that will tell me what to multiply the 5 by. So almost like I'm distributing 1, 2, 3, I'm going to take 3 to the 1 times 5, m to the 2 times 5, and p to the 4 times 5. So essentially, I'm multiplying, and I'm raising 3 to the 5th power, because 1 times 5 is 5. So you're essentially raising this coefficient to the 5th power, because 1 times 5 is 5. M, 2 times 5 is 10, 4 times 5 is 20, and I drag down the 6. Don't forget the 6. Okay, so then all I have to do is this front work. So again, with my calculator, if I take, get you out of the glare there, 6 times 3 caret to the 5th power, there's my 1458. And then my m to the 10th, p to the 20th. So obviously much faster when you use the shortcuts. It is the same answer as we got here, but don't feel like you have to use them if you're not comfortable. Okay, last but not least, we've got a fraction. No big deal. Don't be afraid of it. Just follow the same protocol. So we've got quantity, 3x to the 4th divided by 8y to the 5th, and we're taking all of this to the 2nd power. No biggie. We know that means write it twice. So I've got 3x to the 4th divided by 8y to the 5th times itself. 3x to the 4th divided by 8y to the 5th. So that takes care of this. Now I'm going to keep going. Okay, on top here, I've got a 3 times 1, 2, 3, 4 x's over an 8 times 5 y's. And I'll do it all over again. And also with the 8 and the y's. So I broke it down, and now I'm ready to build it back up. Here we go. Go straight across the top, because when you multiply fractions, you do top times top, bottom times bottom. Okay? So here we go. 3 times 3 is 9. Count your x's. 1, 2, 3, 4, 5, 6, 7, 8. So 9x to the 8th over 8 times 8, that's 64. Count your y's. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So 64y to the 10th. 9/64ths does not reduce. If it did, I would handle that. But 9 over 64 stays as it is. So this would be the final answer. Now, if you're shortcutting it, again, don't want to ignore you if you're shortcutting it. Let me recopy the problem on the back and show you how that would go. So you had 3x to the 4th over 8y to the 5th, and this was all squared. So if you're shortcutting this, don't forget, put your 1s as your exponents on your constants and proceed. So you have to take the 2 times the 1 and the 2 times the 4. So 3 to the 1 times 2, x to the 4 times 2 over, and now you have to do it on the bottom as well, 2 to the 5 and 2 to the 1. So 8 to the 1 times 2, y to the 5 times 2. This gives us 3 to the 2nd power, 1 times 2 is 2, x to the 8th, 8 to the 2nd, y to the 10th, and then just using your knowledge of squaring, 3 times 3, 3 squared is 9, x to the 8th, 8 times 8, 64, y to the 10th. And you got the same answer both ways. So, again, think about your comfort level, and just know, even if you go shortcuts, but then you get to a test or a quiz and you forget the shortcut, you always have writing it out as backup. Okay, thanks for watching.